Right, welcome to revisionug.com, a learning platform which provides education in its simplicity. My dear students over there, this is our chemistry lesson in number 3. In this lesson, we are going to look at moles of water of crystallization. Right, moles of water of crystallization. So the word crystallization comes from the word crystals. In chemistry, we do have different compounds and with different chemical characteristics. So we have some compounds that form crystals by the help of water, and this water is just a specific amount which is needed to make them crystallize. So that process of becoming crystals is what we call crystallization, and that water they do need to make crystals from their solutions, from their aqueous solutions, is what we call a water of crystallization. Therefore, a water of crystallization is a fixed amount of water with which some substances chemically combine when they form crystals from their aqueous solutions. For example, we have copper 2 sulfate, and this copper 2 sulfate it is a hydrate, so it is called copper 2 pentahydrate. We have sodium carbonate, which is sodium decahydrate. We have magnesium sulfate, that is septahydrate, and very many others. So in this lesson, we are going to learn how to calculate the amount of water vapor, that specific amount which is needed. Let us get started. Remember, this is Revision UG, where we provide well organized notes that are easily read and understood, quizzes and test papers. Please try to follow us using the links below. Okay, when sodium carbonate crystals, sodium carbonate X hydrate, were heated strongly, there was a loss in mass of 62.9%. This is not L, this is percentage. What is the formula of the crystal? Meaning that they want us to get the value of X there. And but again, the question says that when you heated, or when they heated sodium carbonate crystals, there was a certain weight which was lost automatically, because it is a water of crystallization. I mean, it is a crystal, so it is having water of crystallization. Therefore, on heating, it lost its water of crystallization. Now, as we did in the previous lesson, where we are getting empirical formula, here we are not going to start with the elements. We are now going to deal with the compounds. So let us state the compounds that we are having there. One, we are having sodium carbonate, this one sodium carbonate, and still another one is water. Then after writing that, we have to write the masses given in terms of percentages or in terms of grams. Here it is given in terms of percentages. They are saying that 62.9% was lost. So if it was lost, what was that one? That was the water which was lost. Therefore, this 62.9% comes here. Because it was a percentage, what is the balance? Then 100%, take away 100%, take away 100%, take away 62.9%. Okay, let us compute this one using the calculator here, my calculator, right? Okay, 100 take away 62.9. so what's the percent? What's the answer? So the answer is 37.1%. So that is sodium carbonate. So after that one, we get their relative formula mass. In the previous empirical formula which we have been doing, we have been getting the relative atomic masses, but here we are getting relative formula mass. For sodium carbonate, let us do it from a side here. Sodium atoms, there are 2 there, then plus 1 carbon atom, then plus 3 oxygen atoms. Each atom for sodium, it is 23 times 2, then carbon is 12, then oxygen is 16, then by 3. So this is 46, then plus 12, then plus 48, a total of 106. So this is 106. Then water, 2 hydrogen atoms and 1 oxygen atom. These are 2, then plus 16, and then when you add you get 18. So it is 18 there. Then after that we get the number of moles. So number of moles, we are going to get the mass, that is 37.1 divided by 106. Then here 62.9 divided by 18. Okay, now let us start with 37.1 divided by 106. Then this is giving us 0.35. Then let us also get to compute 62.9 divided by 18. This is giving us a 3.49. So we are getting the mole ratio. So remember we said that mole ratio, we get the smallest moles, we divide them throughout. So 0.5 is the smallest, 0.5, and then here also 0.035. This is a 1. Then 3.49 divided by 0.35. This one gives us 9.8. So this one gives us 9.98. So when you round off, this is a 10, then we put here also 10. Therefore when you round off, this one becomes 10. Therefore the simplest ratio is 1 to 10. So the empirical formula is going to be a sodium carbonate, whereby it's 1. Then water of crystallization, this 10 represents 10 molecules of water of crystallization. So when we are answering the question now, the value of x is now x is equal to 10. Therefore the formula is a sodium carbonate 10 water, which is a sodium carbonate decahydrate, because deca is 10, hydrate that's water, so this is hydrated sodium carbonate, right? Okay, now let us get to see another example here. This example says a white crystalline salt X water of crystallization contained 51% of water of crystallization. If this is saying if the formula mass of the hydra salt is 120, what is the formula of the crystal? Now let us start with our compound here. So we have two compounds, compound X and compound water. Then we have masses. So the masses, water takes 51.2 in terms of percentages. Therefore let us get a balance. 51.2. what's the balance here? This is 100 minus 51.2, or how we remain with the 48 here, 48. Then so our M is 48.8%. Let us get their relative formula mass. This one is automatically given 120, and for water is automatically 18. Then what next here is to get the number of moles, right? To get a number of moles, that is 48.8 divided by 120 and 51.2 divided by 18. Let us now divide that. So 48.8, we are dividing it by 120. The answer is 0.40. Then let us also divide 51.2 divided by 18. Now here it is giving us 2.84. So we are going to get molar ratio. Remember, molar ratio, we are getting the smallest, so 0.40 is the smallest, 40, and then 2.84 divided by 0.40. This is a 1. Then here we divide it by 0.40. What are we getting? We are getting 7. Therefore the formula for the crystal is crystalline salt is M the septahydrate, like this, whereby the value for X is 7. So there are 7 molecules of water of crystallization. Here comes this other example, which says that Yes, says. Yeah, right. When 5 grams of hydrate of copper 2 sulfate were heated to a constant mass, 3.2 grams of the hydrous salt remained. Remember, we have the word hydrous, this word hydrous, and the word hydrate. Hydrate means there is water, then hydrous means it lacks water. Then when you look at this copper 2 sulfate pentahydrate, okay, copper 2 sulfate hydrated, we use it to test anhydrous copper 2 sulfate. We use it to test for the presence of water. If there is water, then it will turn blue. That means that now it is hydrated. When there is no water, then it remains white, which means that it is now hydrous. Okay, so let us see how we are going to go about this question. Still, we are starting with a compound. The compound, we have the copper 2 sulfate. Remember, I told you have to be all versed with writing the chemical formulas of different compounds, and also water, which is the X, which we don't know. And then relative formula. No, sorry, before getting the right. Before getting the relative formula masses, we get the mass. The mass given, they're saying 3.2 grams of hydrous. Now that is the copper 2 sulfate, which is 3.2. Now remember, all of it with water, it was 5. Now so far we've heated, then the water has gone, we have remained with the 3.2. Now how much water was there which escaped? Let us subtract. 5 take away 3.2. what's the answer? 1.8. So it is 1.8. Let us get the relative formula masses. So water automatically is 18. Let us get for copper 2 sulfate. Copper is 63.5 plus sulfur, which is 32, plus oxygen, which is 64. Remember, it is 16 times 4 because there are 4 what? Atoms, right? Now let us add this one. 64 add on 32, then you add on also 63.5. So we are 63.5. sorry, I have made an error. Then add on 32, then we add on 64 again, then it's giving us 159.5. So this is 159.5. Then let us get a number of moles. That is 3.2 divided by 15, 159.5, then 1.8 divided by 18. So let us divide that. This is 3.2 divided by 159.5. What's the answer? Here we have 0.02. Then let us get this one. 1.8 divide it by 18. So this is giving us 0.1. So we divide. Now we get the molar ratio. Divide out throughout by the smallest, which is 0.2, which is 0.02. Now this is a 1, and then this is divided by 0.2. Which is 0.1 divided by 0.02, which is a 5. Therefore, the value of X is 5. So it is copper 2 sulfate pentahydrate. Okay, now let us look at one more other example, and this is here. This one says, this example says, when 5.27 grams of a hydrate sodium carbonate were heated to a constant mass, 2.12 of the hydrous salt remained. If the formula of the hydrate is that, calculate the value of X. Let us calculate the value of X. What is our compound here? The compound 1, we have the sodium. Let us we have sodium carbonate. This is sodium carbonate, and also there is water of crystallization. Let us get their masses. what remained was 2.12 anhydrous, which is now copper to carbon, no, sodium carbonate, sorry. All of it was 55.75. All of it was 5.27. Then let us subtract, let us take off the 2.12, which is giving us 3.15. Let us get the relative molar masses. So this one, it is 106, then the water automatically is 18. Let us get now the number of moles, which is 2.12 divided by 106. Then this is 3.15 divided by 18. Let us start dividing. Now 3.15 divide it by 18, and we are getting 0.175. Then let us also divide 2.12 divide by 106. This is giving us 0.02. Now the task is to know which one is the smallest, which one is the biggest. And I told you, if you get confused, you can use the LCM, whereby this is 0.2, it is 1, 2, 0.02, which is 1, 2, which is 2 out of 100, then 0.175, which is 1, 2, 3, which is 175 out of 100, out of 1,000, sorry. Then the LCM, what's the LCM there? The LCM is 100, that is 2 out of 100 times 100, then 175 out of 1,000 times 100. Then this 100 here remain with the 2, then this 100 will go with this one, so 75 out of 10, which is 7.5 still, right? Still it is still the same. If we take by 1,000, then even by 1,000, this will be 175, then this will be 20. Still this one will be small, this one will be the biggest. Therefore this one is the smaller. Now when you are getting the molar ratio, so this one is the smallest, 0.02, and again this one 0.02. now these ones will cancel, we remain with the 1. Then let us divide this one, 0.175 divided by 0.02, right? So it is giving us this one is giving us 8. It is giving us 8. So this is 8. Therefore it is the simplicity ratio is 1 to 8. Therefore it is 8 here. So I think this is the last example we've had in this session, in this lesson. You've been a good learner. So this is revisionug.com. Below the video we have the organized notes. Please try to read, to copy them, read them. They are easy to read and understand. The task is also awaiting for you. Please follow us using our social media links down the video. We meet in the next lesson. May God bless you.